Okay, well, welcome to our research coil for April 25th, 2023. I'm Lori with Behavior Education at Spirit Keeper Animal Sanctuary. This is specifically for my Patreon community. We do this once a month. And this month, we reviewed a paper, or I sent out a peer-reviewed journal article on Cryptosporidium in snakes. And it was a review article by Bogan in 2019. And that is cited here on the title slide. I will cite it again at the end. If anything is in quotations during the presentation, I took that directly from the paper. If I took anything and added it to this presentation that wasn't directly from the paper, I added citations for that on the individual slides. So this is a review of Cryptosporidium in snakes. And it's pretty scary, as Natalia already mentioned, it can be. So let's just get right into it. We're going to go over what Cryptosporidium is, what cryptosporidiosis is, and how it impacts snakes, and how that is different than how it may potentially impact other animals. Okay, so Cryptosporidium is a parasite. So this is not a virus, it's not a bacteria, it is a single-celled animal. So it can live a very, very long time outside of the host organism, which is a little bit unusual for some parasites. Some parasites need to live inside of the host organism. And if they're outside of the host for very long, they die, they don't survive. But Cryptosporidium is different. It can live a long time in the environment as an oocyst. And that is a round cyst that contains the fertilized egg of the parasite. So by the time it's this oocyst, it's already fertilized and can basically hatch into the organism. But when it's in this state of being in this cyst, and that's what's pictured here on the slide, it is a very strong outer case that this parasite is inside of. And it is very, very difficult to penetrate, very, very difficult to break down and kill. So when these little oocysts are in the environment, they can live for a really long time, and it's really, really difficult to get rid of them. And if you scrub, so viruses typically, many viruses you can get rid of in the environment just by scrubbing a surface, even if you're not using soap and water or disinfectant. Some viruses are so delicate in the environment that just by scrubbing alone, you can get rid of them. Well, if you scrub a surface that has this oocyst of the crypto, you're just spreading it around more. You're not necessarily breaking through the outer shell and killing the organism at all. You may just be spreading it to more surfaces and getting it on your rag or on your brush, and then spreading that to another enclosure that you clean after. So that's why this in particular is pretty scary. So the species that snakes are host to is Cryptosporidium serpentis. There are different species of Cryptosporidium that can infect different types of animals. I'll talk just a little bit about that, but the one specific to snakes is the Cryptosporidium serpentis. Now, Cryptosporidium is the organism. Cryptosporidiosis is the disease that it causes. And in layman's terms, everybody just calls both crypto. So I'm going to, at some point, start just saying crypto, and that can mean the organism, or it can mean the actual disease that it causes. So these are pictures of some of the different species of Cryptosporidium. Now, this Cryptosporidium parvum and Cryptosporidium hominis are the ones that can infect dogs, humans. It's really common in cattle. Calves carry this a lot. So these two forms, the hominis and the parvum, that's what you're going to hear about a lot if you go to the CDC website. If there's an outbreak, usually in a city among people, or calves or dogs. So those two forms can infect a lot of mammals. Those are zoonotic, which means that they can spread between different species. This is not the same type that infects the snakes. These two types in particular, usually the body will rid itself of them. There's no cure, but after a couple of weeks, which when you hear the symptoms, a couple of weeks of these symptoms would be horrific, but if you can make it a couple of weeks of abdominal cramping and vomiting and diarrhea and inappetence, and intestinal pain, usually you're okay. But if you're immunocompromised or you have other stuff going on or you become too dehydrated, et cetera, it can be fatal in some people. So the parvum and the hominis species are the ones that infect people, dogs, cattle, some other mammals. This is not the same type that infects the snakes. So this is a picture of the oocysts actually encysted into tissue of a snake. So what happens is those round oocysts get inside the body through ingestion, and they make their way to the gastrointestinal system. It's very common for them to attach themselves to the tissue in the stomach or the intestines, and they just sit in there in the tissue until the little organisms inside hatch out. And so cryptosporidiosis is the disease that the organism Cryptosporidium causes, and it can be very severe and life-threatening in snakes. And typically it causes gastric cryptosporidiosis, which basically is the cryptosporidiosis disease, and it impacts the stomach or the intestines, the gastrointestinal tract. So as of when this paper was published, this particular disease is not known to be zoonotic, meaning the species that infects snakes, to the best of our knowledge or the author's knowledge when this was written, it is not transmissible to humans or other non-reptilian species. Like I could ingest it and I might be able to carry it and have it live inside me and pass it on, but it's unlikely to make me sick. And that is something that's called a pseudoparasite. So if this form of crypto was able to live inside a human host and not infect us, it's considered a pseudoparasite, and we could pass it on into the environment, and then a snake or a reptile could get it. So it typically causes this gastric mucosal hypertrophy, which is an inflammation of the mucosa in the gastrointestinal tract. And that hypertrophy just means there's an overgrowth of cells. So if somebody has muscles that are hypertrophic, it means their muscles have grown enlarged. And so if you think of atrophy, that's when the muscles get smaller and are reduced. So hypertrophy is when something's enlarged, and that's just the mucosa becoming enlarged due to inflammation. This is what it can look like on the outside of a snake. So this would be a snake that has symptoms, that is clinically symptomatic for crypto. You're likely going to see this abdominal swelling, and it'll become more clear why this manifests in just a minute. So how is this transmitted? Well, it's direct through fecal oral route, or indirect through feces or vomitus contaminated environment. So that means that if a snake is ingesting feces from an infected animal, then it's going to get it. Or if somehow it ingests feces or vomit from the environment, from a surface, then it's going to get contaminated with this parasite. So if, for example, a snake eats another snake that is carrying it, or eats a rodent that's carrying it, even if it's not the species that makes the rodent sick, if the rodent has this snake species inside it and the snake eats the rodent, then it's going to get sick. All right, so if there's feces or vomit in the environment, and the snake is eating in that environment, and the prey gets rubbed on the feces or vomit, and then the snake ingests it, or the snake is rubbing its mouth after eating or to get substrate out of its mouth, and it ingests any particles of feces or vomit that are infected, it is going to get infected with this parasite, because those little round oocysts that I showed you, they just live on surfaces in the environment, in the feces and the vomit in other organisms, and they just live in there in their little protected orb until they get inside their preferred host, and then they attach themselves to the stomach or intestinal lining, and then they start hatching. So basically the snake somehow ingests that oocyst, and excistation occurs. And excistation, I'll show you a picture in a minute, is when that cyst bursts open and these sporozoites are released, and 4 of them are always released. And those are actual little living things that are mobile. So these oocysts aren't self-mobile. They're just wherever they happen to land, and the snake ingests them. But once they break open and these little organisms come out, now they're mobile and they can move around on their own. And that's how they invade additional cells in the stomach and intestines. And so then from there, they transition to something called trophozoites. And this is the growth phase of the organism. And this is when the parasite starts absorbing nutrients from the host cell. So this is where you're starting to see weight loss, anorexia, because the nutrients that should be going to the snake are now going to this little parasite creature. All right, so here's what that looks like. The photos on the right, let's start there. So they're all safe in their little ball. And then when the time is right, and when they're in the right host, that ball, that oocyst, that casing that is so tough and durable breaks open. And 4 of these little creatures emerge. And that's the mobile form, the motile form, those ones that can move around now and individually invade more cells. This picture on the right just shows what the oocysts actually look like. So the oocyst is the round ball with the 4 creatures inside it. It's really super durable. It's like a coat of armor. And then when it breaks open, those sporozoites, 4 of them, come out. And then that's what starts invading cells. And then from there, they transform into the phase, the trophozoites, that start growing and start consuming nutrients from the host. So this is all icky. Like, I wouldn't want this inside my body. And when this happens inside your snake's body, it's usually fatal for them. Here's the whole life cycle. So let's start with the sporozoite on the very far left top. That's the little creature that actually can move around. And then it becomes the trophozoite, where it's growing and it's consuming nutrients. And then there's a few stages where it reproduces, and it can reproduce asexually or sexually. And then it produces the next generation of the little wiggly worm creature. And then it gathers together with 3 others into one of those oocysts, and it exits the body somehow. Either the animal dies and the oocysts are deposited after the animal decomposes, or it exits the body through regurgitation or through the feces. And then that oocyst is ingested by something else, and the whole process starts again. So the impacts to the snake are, now remember, the parasite itself can reproduce sexually or asexually. And as it's doing that, it's causing damage to the host, because it is causing inflammation and all this stuff with the tissues, and it's taking the nutrients the snake should have, and it's using them to grow and reproduce. So this next part is directly from the paper. The ophidian host, that's the snake, response to Cryptosporidium serpentis includes mucosal hypertrophy with exaggerated edematous longitudinal rugae, copious mucus production, and mucosal petechiae, and brush border hemorrhage. So I've given you some little terms here at the lower right, because I understand everybody might not know what all this means. So hypertrophy is just the overgrowth of cells. Edema is excess fluid in the tissues. Petechia is little red or purple dots or spots, and it's from capillaries bursting and hemorrhaging. And then brush border are these little microvilli that cover the surface of organ tissue.
Because I was spinning the one.
And so basically all of that gets infected by this parasite, and its whole life cycle inside the organism causes all of these changes to occur, which causes the snake not to be able to eat and digest nutrients normally. It causes regurgitation, it causes intestinal and gastric pain, it causes hemorrhaging inside of the gastric tissue and the intestinal tract. It's horrible. So the snake cannot live in this state with this going on inside the body. So the infected snake may be subclinical, and that means asymptomatic, or it may be clinical, and that means that it has symptoms. So if it's asymptomatic, we'll talk about that in a minute. It means it's got this parasite inside it, but it's not sick, it's not having any symptoms. and you may not know that it has it. And that's what can be really scary, because it could get sick later, or it could pass these little things to other snakes that will get sick, even though the host itself isn't. If the snake has clinical signs, that means it's symptomatic, it is sick, it has the parasite and it is sick. Then you've got this massive gastric mucosal hypertrophy, and it narrows the gastric lumen. And this makes it basically so the snake can't swallow and pass the food through the intestinal system. The digestive tract cannot now accommodate the food to pass through, so it regurgitates. And then the snake is going to become lethargic and anorexic because it's not getting food, it's not getting nutrients. Now it's immunocompromised from all of this hemorrhaging and stuff going on inside of the body. And so it's just going to progressively decline in its state of health. And the stomach may enlarge and cause a palpable, that means you can feel it but not see it, or visible mid-body bulge. And that again is this picture that I showed you before. This is a visible mid-body bulge that is common in crypto with a snake that is infected with it and symptomatic. So secondary intussusception can occur, and an intussusception means a portion of the intestine sort of folds, and it can actually telescope in on itself, or one segment can slip inside the other. And of course, if that happens, nothing can pass through it. It can also cut off blood flow to the intestinal tissue, which means the intestine becomes necrotic and dies. And so it's just not working at all. And that can happen in some cases of crypto, just secondary to all this other stuff that's happening, which is also horrible. That's very painful. This is a type of colic that can actually also happen in horses, and it's super painful, and it requires surgery or euthanasia to fix. All right, I know this is really disgusting. So this is this bulge on the right. We've already looked at this picture several times. The photo on the left is what's happening inside the snake when it gets to the point where you're seeing this visible bulge. So what we're seeing here is a deceased snake on necropsy that is laying on its right side with its head to the left. So if you were looking straight on at this picture, the snake's head would be to your left, and the snake is laying on its right side, and the stomach has been cut open. And what you're seeing is the lining of the stomach. It should not look like that. So the snake's stomach has these folds in it called rugae, and they're really small and reduced when there's no food in the stomach. And the rugae are present so that when a huge meal or food is in the stomach, these folds now can expand, they unfold, and it causes the stomach to expand. And the stomach lining becomes smooth while it has the prey in there, because none of these folds are there anymore. Well, in a crypto snake, one that is ill because of this parasite, these rugae, even in an empty stomach, which this is, become so inflamed that they enlarge, and they shouldn't be enlarged. So they aren't unfolding and making the stomach cavity bigger. The rugae themselves are staying folded up, and the tissue itself is becoming inflamed. There may be hemorrhaging in it, edema, which is fluid buildup in it. And basically the stomach's being filled up by its own rugae. And this is what happens. And that's what causes that bulge. And obviously no food is going to fit in that stomach now. Okay, I know that was disgusting. I feel so sorry for any snake that gets this. So it's not known at all why some snakes remain asymptomatic and others become symptomatic, but there are some people that speculate that contributing factors could be general stress, that's psychological and emotional and environmental stress. The environment itself, if something in the environment isn't correct, isn't right, isn't proper. Oxidative stress, and that's something that goes on inside of the body where the oxidative process just starts getting out of control and is overworking. Immunosuppression, which is basically the snake's immune system, is suppressed for some other reason. And that could be because of a concurrent infection with something else. So let's say the snake has nidovirus, or is infected with a different parasite, or just has some illness that's causing its immune system to already be working on that and immunosuppressed, then the crypto can take hold. and it can manifest more easily because the immune system is already compromised. Okay, so how do you diagnose this? Well, it all depends highly on choosing or obtaining the best sample. That means obtaining a sample that is likely to have the highest count of the parasite. And then you also want to choose the best testing method. And that means choosing a testing method with a really high level of sensitivity that can detect the parasite at the lowest possible numbers in the sample that you have. So asymptomatic snakes have been shown to shed only 400 to 400,000 oocysts per milliliter. Now, that sounds like a lot, but in mammals, like if we had it or a dog had it, we would be shedding millions of these oocysts in our feces or vomit, like 3 million to 7 million of these oocysts in 1 milliliter, whereas a snake is only going to shed maybe 400 to 400,000 on average. Okay, so you need a viable sample of feces, vomit, tissue, and then you need to use a testing method with the best sensitivity able to detect these oocysts in the lowest amounts that they might be present. So you can take samples externally or internally. So feces, vomit, or a cloacal swab would be considered external samples. These are not going to be as good, as effective at detecting the oocysts as an internal sample, which would be something like a biopsy, a gastric lavage, or a gastric swabbing. So a biopsy is actually taking a tissue sample and checking for the oocysts. A gastric lavage would be basically you flush water into the stomach or the intestines, and then you suck it back out and you sample that. And gastric swabbing is you're actually sticking a swab down into the stomach or intestines, and you're getting, like you would swab the mouth or the cloaca, you're actually getting a swab like that from inside the snake, and you're testing that. So clearly, internal sample collection is a big deal. These are not things you're going to do with the snake awake. You're going to have to do this with the snake under sedation. And if it's already immunocompromised, sedation or anesthesia is going to be risky. So I have a snake here, Starburst, who went up to Colorado State University to get tested for basically everything that could possibly be wrong with him because we didn't know what was making him sick. He was anesthetized and he had a lung wash. So they put fluid down in his lung and took samples directly from his lung so that we could send those off for testing. That was risky because he was already having respiratory issues, but he survived okay. And he doesn't have crypto. Turns out he has nido. But I just wanted to say that while the internal sample collection methods are preferred and going to be more accurate, they're a bigger deal if your snake isn't feeling well. Okay, they're riskier. All right, so testing methods that are possible include fecal direct or flotation. So that means you just take a fecal sample, or you could do this with vomit, and you just put it on a microscope slide and you look at it directly, or you float it in a liquid solution, and then you look at that liquid solution under the microscope. They can do acid-fast staining, and that determines if a sample of tissue, blood, or other body substance like feces or vomit is infected. You can do an IFA, that's an immunofluorescence assay, and that is to detect antibodies in the sample. And then an ELISA, enzyme-linked immunoassay, is the same thing, and that's going to detect antibodies in the blood. So these two, the IFA and the ELISA, are going to detect antibodies that the body starts producing because that parasite is present and making it sick. But according to this paper, and again, this was a review of all of the literature about crypto and snakes, a PCR or polymerase chain reaction assay, which is a molecular analysis of a sample, and it's designed to detect the presence of DNA inside the organism. So it's designed to detect the presence of the parasitic DNA inside of the snake, is the most effective. So they said when compared to the other testing options, Cryptosporidium PCR is considered the most sensitive because it has the ability to reliably detect samples with oocyst concentrations as low as 40 per milliliter. So some of the other tests that are listed here you would need the presence of something like 700,000 oocysts before they would be picked up in some of these other sampling methods. And there's a whole chart in the paper that details these and how many need to be present if you're using each of these methods, but the most accurate is this PCR can detect as few as 40. And just here's an example. This is in the paper. Here's an example of 4 of the tests listed. So the acid fast stain, it would need a minimum of 75,000 oocysts to turn up in that test. And then the ELISA would need about 17,500. That is the speed that a spacecraft has to be going at to orbit the Earth without falling back to the planet. I didn't notice that until just now. So there's a fun fact for you. The IFA, you need a minimum of 4,000 organisms or oocysts to pick up, but the PCR, you only need 40. So you can see why they're saying that that's the most effective method, because it has the most sensitive ability to detect the organism in the sample. All right, so how common is crypto in reptiles or in snakes? There are all kinds of estimates and reports that indicate anywhere from 4.8% to 35% of reptiles have crypto. And this is captive reptiles worldwide. And why there's such a huge range is this information is based on all of these different testing methods, and whichever testing method was used by whichever researchers were producing these different papers in these different parts of the world. So it isn't that these statistics are coming from one sampling method all done the same. It's coming from a whole bunch of different sampling methods all over. So that's why there's such like 5 to 35%. That's a big range. And some of these were done through fecal testing. Those are the ones where you're probably going to get a lower percentage, and some were done through PCR, which is probably going to give you a higher percentage. So it's present in reptiles. It's present in snakes. It's present in other reptiles. The prevalence of it, we're not sure, but it could be as much as 35% or lower. All right, so is there a treatment? That's our big question, because our snake gets sick, we want to treat it. Well, to date, there has not been any treatment shown to be completely effective in treating cryptosporidiosis in any species. So I did that supplemental video about crypto in general, that it infects humans and dogs. And there's no treatment in us. There's no treatment in our dog. It's just that we are able to rid our bodies of the type of crypto, the species that infects us. Snakes are generally not able to do that. Some can, but that is more rare than a snake getting infested with it and it becoming fatal. So a drug called paromomycin has been the drug that has shown the most promise. And the paper details a whole bunch of different treatments that have been tried in a whole bunch of different species, including snakes. This one has shown the most promise in reptiles, and it is only based on trying it in 4 reptiles: a king cobra, a bearded dragon, and 2 Gila monsters. So depending on which species, the dose is oral. It means you have to give it in the mouth every 24 to 48 hours, or in the case of the cobra, they gave it twice a week for 6 weeks. I want to emphasize that this treatment is for asymptomatic animals that have tested positive, not clinically symptomatic animals. There is nothing we can do for a snake that is clinically symptomatic with the disease. If it is sick and has symptoms, it will die. This treatment is for, let's say you have a sick snake, you know it has crypto, you test all your other snakes and one tests positive and it's not sick, you can right away start treating it. And there has been success getting rid of the crypto, and it's subsequently testing negative for it in these 4 reptiles that were tested. Okay, so this treatment is for an animal that's tested positive but is not sick. So how do we disinfect the environment? I mean, that's the big question. How do we make sure we don't get this in our environment in the first place? So freezing prey to at least -15 Celsius or 5 degrees Fahrenheit before feeding it to the snake will inactivate the crypto parasite. It will inactivate the oocyte. Notice that the paper didn't say kill, it says inactivate. So take that for what it is, but freezing it. So we want to freeze our food before we're feeding it out. Cleaning the enclosure, the surfaces, and fomites. Fomites are things that the parasite or the oocyst can come to rest on, like utensils, bags, dishes, our hands, anything, with a proper disinfectant. So we're going to talk about what a proper disinfectant for this particular parasite is in a minute. Remember, when we're talking about disinfection, that the goal is minimum inactivation of 99.5% for disinfectant. So that means 99.5% of the organism is inactivated if we use this particular disinfectant, not 70%, not 50%. We wouldn't want to use a disinfectant that's only inactivating 50% of the little crypto creatures. We want almost 100% inactivation. Otherwise, our biosecurity is really not effective. All right, so what disinfectant should we be using? All right, ammonia gas at a concentration of 5% for 18 hours of contact time, or 6.64% liquid ammonia for 24 hours is effective in inactivating the Cryptosporidium oocyst. This is not your household ammonia. This is special ammonia that you're going to have to get somewhere. And I want to emphasize this: ammonia releases harmful fumes that can irritate eyes, mucous membranes, the respiratory tract, not just in us, but in our other pets and our snakes. And the irritation can be severe enough to cause chronic respiratory issues for life or death. So I do not use ammonia in my facility, but it is an option. And I needed to let you guys know that. This is what I use. Hydrogen peroxide is effective at inactivating Cryptosporidium oocyst so long as the concentration is at least 6%. Again, this is not your household hydrogen peroxide. This is food grade hydrogen peroxide. You can get it on Amazon.com up to 12%. And that's actually what I have here is the 12%. Not that it's necessarily going to be more effective because you end up diluting it with water and using it, but you don't want to dilute it below 6%. It's just that that was what was cheapest and most accessible, and that's what I ended up getting. So you want a concentration of at least 6%. So if you buy a concentration that is already 6% and use that to disinfect, you don't want to dilute it. You want to use it direct. If you're getting a concentration that's higher than that, like the 12%, you can dilute it down to 6%. You don't have to. I don't. Well, I do sometimes. It's really strong and irritating. If you get it on your skin, it burns. It needs to be on a surface for 20 minutes, and then you can wipe it off. So once you've wiped it off after that 20-minute time, it's not going to harm you or your lungs or your animals. So this is what we use here. There are other things. There's a big chart in the paper that lists other options, but these were the most effective. And honestly, the hydrogen peroxide is the most accessible, I think, to the normal pet owner, because I literally get mine from Amazon.com. And it comes in big gallon jugs and it shows up at my door. And 20 minutes on a surface or in contact with something else, and it's 99.9% effective against the Cryptosporidium. Don't ingest it, and don't let your animals ingest it. This doesn't mean if the animal drinks it, it's going to kill the crypto inside their body. This is for surfaces. I want to be clear. Nobody think that you can like feed this to your snake or to you. All right, so what should your protocols be? Well, quarantine new snakes for sure. And you want to make sure that you're not seeing signs of this gastric bulge, diarrhea, regurgitation, lethargy, anorexia, inappetence, any of those things that were listed as symptoms in the paper. You want to isolate 6 snakes pending diagnostics. So if you've got a snake in quarantine or one of your current snakes gets sick, you want to isolate it immediately until you figure out why it's sick. It may not be crypto, but you need to isolate it and figure out why it is sick and if it has something that is contagious. So for example, here I've noticed gastric bulging in some snakes. I've had that diagnosed. It's been cancer, unfortunately. Well, I mean, on the one hand, I say, unfortunately, cancer is not contagious. So In those cases, those snakes didn't have to go into quarantine or isolation. They had cancer. We knew what was wrong with them. They didn't have anything contagious. But until you know that, you need to isolate the snake. If one of your snakes tests positive with some type of crypto or other disease that is contagious, then you need to thoroughly screen all of your snakes. So let's say you get a new snake, you quarantine it. Let's say you just do a regular proactive fecal check. Like you don't even think it's sick. It's not showing symptoms and you just do a fecal check and it comes back that it has crypto. Well, you absolutely need to do a more thorough screening of that snake. And it's recommended then at that point that you do the internal diagnostics. So an intestinal or a biopsy or an intestinal wash or lavage or that direct swabbing from internally just to confirm the diagnosis and get a better idea of what you're dealing with. But then you want to check all your snakes. If one tests positive, then you're going to have to screen all of them. Isolate snakes testing positive and then confirm that positive test with more thorough testing. Any asymptomatic snake that tests positive, that means one that tests positive but is not sick and then subsequently tests negative, may have rid itself of the virus, but it is perpetually, forever considered a high risk. Okay. And the reason is that if it got it once, maybe it's susceptible to getting it again. And maybe it didn't get rid of 100% of all of the oocysts and it's just not sick from it. And so remember, even the most sensitive test can only detect 40 of them in a milliliter. So let's say your snake almost rids itself of all of them. And maybe there's not enough in the sample to show up on the test. Then it's going to show negative, but the snake still has it. So that's why they're saying if a snake is tested positive and now isn't sick and then tests negative, it's always a risk. And then you need to have dedicated space and equipment for infected snakes. And when I'm saying up to this point, infected snakes, these are ones that have it but are not sick. Because symptomatic snakes, those that are sick, should be euthanized because it's a terrible illness. And once they're sick from it, like actually ill, there is nothing that you can do to fix it, to cure it. It's not going to rid itself of the virus. Once it's to that point, it's going to be fatal. And the most humane thing that you can do is to euthanize it. Okay, well, on that really high, happy note, we're going to have our discussion. So I'm going to turn off the recording and then we can talk about this.